Okay, so here we have a problem with a mass of 2 kilograms on an inclined surface, a rough inclined surface, so we're going to have to deal with friction. We're told that the tan of the angle is 4 over 3. We can use that, I'll show you in a second, to work out the sine and cos of that angle. We've got a coefficient of friction between the particle and the plane of 1/2. So first thing is we have to show the forces acting on the particle. So the forces that are affecting this particle are, in the first instance, the force of gravity. That's given by, well, as all forces can be pretty much worked out by, force is equal to mass times acceleration. In this case it's 2 by gravity, which is 20 newtons, and it's the force we call weight. Now, we're told that there's a coefficient of friction involved here as well, so we have another force this way, so it's experiencing a force in this direction, and that'll be the force of friction. So I'll just write that in there, friction. Now, friction is always equal to the reaction force times the coefficient of static friction, which we're given. I'll just show that in the same highlighted colour as we've got that in there. The final thing then we have to put in is the reaction force. So the reaction force is always perpendicular to the surface, like so. Okay. Now, there's a few more things to think about here. Well, first off, we kind of want to be thinking of the fact that, yeah, well, that's the start. We have to work out the overall acceleration of the particle going down the slope. So to do that, I'm just going to show you something we can use the way we were given this. So we were given this, the tan of this angle is 4 over 3. So we could say that tan is opposite over adjacent. So if you remember your soc ca toa, for remembering which each of these are equal to, so tan of this angle is the opposite over adjacent, and we're told that's the same, or the ratio is 4 is to 3. This opposite side is a value of 4, and this is a value of 3. Now we've got this right angle triangle here, and what we can do now is, that's a right angle there, we can get a value for this hypotenuse here, h, and simply from Pythagoras' theorem. So Pythagoras' theorem, you know that the hypotenuse squared is the sum of the squares of the other two sides. So we know that's 4 squared plus 3 squared, which is 16, plus 9, is equal to 25. So h squared is 25. We want to know what h is. The square root of 25, it's 5. Now, that's quite handy. We've got this really nice triangle here and these handy ratios. So now we know that the cos of this angle, so the cos of alpha is equal to the adjacent over hypotenuse, which is equal to 3 over 5. And the sine of alpha is opposite over hypotenuse, which is 4 over 5. And we should be using these in a few moments. So where to go from here? Well, there's a couple of things I want to do, and I might just take some of that diagram away just so that I can make it look a bit clear. So we've worked out this, we don't need that there anymore. We know that the force is the weight like that. Now what I'm going to do is just to show that we can change this here, and if I just draw this component of the weight, and this component of the weight. Now we've constructed another right angle triangle, and this here is alpha. So if that's 20, that'll be the hypotenuse. So the hypotenuse is 20 in this case, and we've got alpha there. So this force here, which is directly the weight that's acting directly into the surface, which will be equal to the reaction force. That's the reaction there. That force and this force will be the same. So this here would be the adjacent side of this triangle. So we'll be using the cos. So we'll be using that side is equal to the hypotenuse, 20 times cos of the angle. If you remember, we worked out what the cos of the angle is. That's why they gave it to us like that. The cos of the angle is just 3/5. So I'll just sub that in up there, and we have now 20 multiplied by 3/5, which is equal to 4/3, which is 12 newtons. So we know the reaction force is 12 newtons. Now this part of the force that acts in this way, well, this is the opposite side to this angle. There's a way to show this angle is the same as this angle, by the way, but I won't do it in this one. So this side here is the opposite, so we know that the sine of the angle is opposite over the hypotenuse, or this side here, the opposite side, is equal to the hypotenuse times the sine of the angle. Make that a multiplication sign there. So we know the hypotenuse is 20, and we know that the sine of the angle, as before, it's very handy that we have it worked out already. The sine of this angle here is 4/5. So I'll just fill that in. So that is times 4/5. So that will be equal to 16 newtons. Now, so this, the weight, two components of the weight. One is pulling it down this way at a force of 16 newtons. And we've got a frictional force here, which is resisting that movement, which is equal to the reaction force times the coefficient of static friction. So the overall force of this body down, so the overall acceleration of this body in this direction here will be equal to, let's do that again, the overall force of this acceleration of this body down the slope will be equal to the difference between those two forces. The difference between this force and this force. So I might just fill in what exactly the friction is equal to there beside that. So we are given that the coefficient of static friction, we know that the reaction force is 12. We get that from this component of the weight. So it's 12 times the coefficient for static friction, which is a half, it's equal to 6 newtons. We know this here is 16 newtons. So the overall force, and I might make a little bit more space for myself down there. So the overall force, or the net force, will be equal to 16 newtons minus 6 newtons. So this force here, I'll just show that force there. Take away that force there will give us the net force acting that will cause this to fall down. So the net force here in this case is equal to 10 newtons. So if the net force is 10 newtons, what we have then is that we nearly always use this formula, Newton's second law, which is force is equal to mass times acceleration. The question asks for acceleration, but we're given the mass and we're after working out the force. So just to fill that in then, we know that 10 newtons is equal to the mass, which in this case is, I'll just double check, I think it's 2 kilograms. Yeah, 2 kilograms times acceleration. So divide both sides by 2 and we'll get acceleration on its own, and the acceleration is equal to 5 meters per second squared. And that's it. There's our answer.